Welcome. This is Mathisi, Greek word for learning. It focuses on providing insights on different concepts of mathematics, and this channel would release math lectures on a regular basis to provide introductory knowledge to pre-college mathematics. This is math. So here are some questions. First question. Prove that 2 raised to the power 70 plus 3 raised to the power 70. Let's consider it as A. So we have to prove that A is divisible by 3. Or the remainder when A is divided by 13 is 0. A is divisible by 13. Alright, so first we'll see that 2 raised to the power 70 plus 3 raised to the power 70 can be written as 4 raised to the power 35 plus 9 raised to the power 35, where 35 is odd. So there is a theorem which states that if a raised to the power n plus b raised to the power n is where n is odd, then it is divisible by a plus b. So which can be proved easily by taking the Euler's function method and congruency properties. So it means that finally we get to the point where 4 raised to the power 35 plus 9 raised to the power 35 is divisible by 13, and indeed it proves the main question. Alright, so the second question is prove that 1 raised to the power 1997 plus 2 raised to the power 1997 plus up to 1996 raised to the power 1997 is divisible by 1997. So let's take pairs of numbers from the first and the last, and the second last and the second. So it will be like 1 plus 1 raised to the power 1997 plus 1996 raised to the power 1997. Take it as the one group. The second group is 2 raised to the power 1997 plus 1995 raised to the power 1997 up to 998 raised to the power 1997 plus 999 raised to the power 199 and 7. So each one of the group is divisible by 1997 as by the above theorem. It means that the entire expression is divisible by 1997, hence proved. Alright, so the third question is we have to find the remainder when 2 raised to the power 100 is divided by 3. First step, we know that 2 is congruent to 2 mod 3, and if we raise it to the power 5, then it means that 2 raised to the power 5 is congruent to 32 mod 3, and it can be also be said that 2 raised to the power 20 is congruent to 16 mod 3 when it is raised to the power 4. And so when it is again raised to the power 5 both the sides, it shows that 2 raised to the power 100 is congruent to 1 mod 3. It implies that the remainder is 1 and the value of a is 1. Alright, so the third question is we have to find the last digit of 43 raised to the power 17. So the last digit can be calculated by calculating the remainder, which will be given when the number is divided by 10. For example, the last digit of 16 is 10, and the remainder when 16 is divided by 10 is 6. The last digit of 16 is 6, and the remainder also when it is divided by 10 is 6. So we just have to find the remainder in this case. So the first step is we know that 43 is congruent to 3 mod 10, simple calculation, and so we'll raise it to the power 17. So 43 raised to the power 17 is congruent to 3 raised to the power 17 mod 10. It implies that remainder when 3 raised to the power 17 is divided by 10, it is the actual answer. So we also know that 3 raised to the power 4 is equals to 81, and it is congruent to 1 mod 10. It means the remainder is 1 when it is divided by 10. So 3 raised to the power 17 can be written as 3 raised to the power 4 multiplied by 4 plus 1. So the remainder will be 1 multiplied by 1 multiplied by 1 multiplied by 1 multiplied by 3, because we know that when 3 raised to the power 4 is divided by 10, the remainder is 1. So when 3 raised to the power 4 whole raised to the power 4 is divided by 10, the remainders will also be 1 by Euler's function. And so the only thing left is 3. So the 3 will be the remainder when 3 raised to the power 17 is divided by 10. And it is the last digit of the main expression as well, which is 43 raised to the power 17.